This is a Friday Shoes production. Topic today is I can multiply monomials. Follow along on page 547. A monomial is a number, a variable, or a product of a number and one or more variables. Some examples of those are in the box. You have 7 times g to the 6th power, that's a monomial. 6 times m, that's a monomial. 5 to the 2nd power times x to the 2nd power times y to the 4th power. All that whole thing is a monomial. Or just a variable by itself like n, that's a monomial. Or even a number, coefficient, constant, that's a monomial. Even n to the 2nd power is a monomial. Remember that a power has a base and an exponent. Here we have 9 times 9 times 9 times 9. The easy way to write that is with a power where 9 is the base and 4 is the exponent. Exponents are used to show repeated multiplication. Notice how they've taken 3 to the 2nd power and multiplied it by 3 to the 4th power. They've broken it out into their factors. They've then taken those factors and put them all together to show you, hey, look, all those 3's go together, there's 6 of them. And we have 3 as our base and 6 as our exponent. Taking that and extrapolating, look at our key concept here of the product of powers. Pretty simple concept, actually. To multiply powers with the same base, add their exponents. Put it on that base. So look in the number section here. They say 2 to the 4th power times 2 to the 3rd power is actually 2. You just write one of the 2's, and then you add the exponents, put that on top, on the exponent. 2 to the 7th power. Pretty simple. Algebra, same way. Same base, add the exponents. So you have a on the bottom, just add the exponents, m plus n. Let's look at an example. Multiplying those powers, here it is. Find 5 to the 2nd power times 5, expressed using exponents. First off, they're trying to show you, hey look, 5 by itself right here is the same as writing 5 to the 1st power. So, you can see it, they say it here. So, what you do is, since those are the same base, add the exponents, the 2 and the 1. That's what they're doing right there. And when you do that, you have 5 to the 3rd power. Take a look at the second one. Let's talk our way through this one. Find negative 3 times x to the 2nd power times 4x to the 5th power, expressed using exponents. Well, first we got to remember that when we have a multiplication, a bunch of multiplication all pulled together, we can actually switch the order if we would like to, using the commutative and associative properties. So if you look at it, we're going to reorganize and take those coefficients, that negative 3 and that 4, put those together. Now we're going to take those powers and put them together. From there, we're going to notice that those x's, they're the same. Those bases are the same. So let's do the simple math. We take the negative 3 times the 4, we got the negative 12. We've got the x, because the bases are the same, and we're going to add those exponents, 2 plus 5. And of course our answer then will be negative 12 times x to the 7th power. That's your final answer. Let's try these 3 in your notes. You can pause the video if you like. I'm actually going to do them right here for you right now. Let's take our 9 to the 3rd times 9 to the 2nd, which is our a. 9 to the 3rd power times 9 to the 2nd. Notice the 9's are the same. That means the bases are the same. Therefore, we can add the exponents, and that will be our final answer if we're writing it using exponents. So there's your 9 to the 5th power. Let's take a look at B. The base on each one of these, and notice they're missing that little dot there, that still means multiply together. We have 3/5 to the 2nd power times 3/5 to the 9th power. The base is the 3/5. So I'm going to write down 3/5, since that's the common base. And I'm going to add the 2 and the 9 together. And our final answer is going to be 3/5 to the 11th power. How about C? C, very similar to the one we did above here. Let me see if I can actually show that while we're doing this problem. We have negative 2m times negative 8m to the 5th power. All that's being multiplied together. So let's pull those coefficients and put them together. So we'll take those two and multiply them. That's what that dot's doing right there for us. And then let's take this m's, or the m, I should say, and the m to the 5th power, and multiply those together. Don't forget, any letter standing by itself does have an invisible 1 sitting right there. So, first things, let's get the coefficients done. That's going to be 16, negative 2 times negative 8. Hope you didn't use your calculator for that one. M to the 1st times m to the 5th. Well, that's m to the 6th power, because I remember now I'm just supposed to add those up and put one of the m's down here. So it's m to the 6th power with a 16 in front of it. 16 times m to the 6th power. Moving along, take a look at number 3. The population of Groveton is 6 to the 5th power. The population of Putnam is 6 to the 3rd. Times is great. I like that when they say times. I know what I need to do. How many people are in Putnam? Well, population of Putnam is 6 to the 3rd times as great as Groveton is. So I'm going to actually multiply those. 6 to the 3rd times as great as this one, 6 to the 5th. And of course, you remember the bases are the same. We're multiplying. Therefore, we will add the 3 and the 5. Put our base of 6, put our 8 up here, and the answer will be 6 to the 8th people. But I don't have my calculator here, so I'm going to have you do that one on your own. I'm assuming you can do that, get that answer. How about D? This is your check yourself, so you can stop the video and try it on your own. I'm going to do it right here. The Guadalupe River is 2 to the 8th miles long. The Amazon River is almost 2 to the 4th times as long. Find the length of the Amazon River. I like that when they tell me what we're doing. So it is 2 to the 4th times as long. Let's multiply those then. So we have 2 to the 4th times 2 to the 8th. Hopefully this is starting to become real easy for you. You know the bases are the same, and therefore we can add the tops. That's going to be 12. So it's 2 to the 12th miles long. Our last example. Multiplying negative powers. We did this in a previous example, but they follow the same rules. They do have 2 methods here for you, though. So let's find x to the 4th times x to the negative 2 power, expressed using exponents. Well, let's look at their method 1. It looks just like what we did up here before. We have the x's on the bottom, the bases. We have 4 and a negative 2 on the exponent, so we're going to add those together. When you add 4 plus negative 2, you get 2. You put it on that x, and you're done. Same thing we did just above. Method 2 uses the fact that you have to remember that any power that is negative means reciprocal. And the simplest way to remember that is the fraction version, which is it's going to be 1 fraction bar x to the 1st power in this case, because this right here is negative 1. We make it a positive when we put it onto the bottom of a fraction. And reciprocals, remember the negative means reciprocal, and reciprocals when multiplied give you 1. So what they show is x to the 4th, break it out into the factors. X to the negative 2 would be 1 over x, which is the same as 1 over x to the 1st power. They have 2 of those, so that's why they have 2 of those right there. And then, when you actually multiply these together, if you have x's on bottom, they cancel with x's on top, and we're left with x times x, which is x to the 2nd power. Now, I know what you're thinking. I don't know if I'm ever going to use this method too. Well, I'll show you when you might use it in a future lesson. But right now, let's focus on this method, probably the easier one to use. Your turn. Go ahead and pause the video if you like. try these on your own. See if you come up with what I get right here. I'm going to do these in red. So we got 3 to the 8th power times 3 to the negative 2 power. They want us to simplify, but they want us to express using positive exponents. We got to make sure that at the end we don't have any negative exponents in our answer. So let's take a look. Same rules apply. We have 3 to the 8th times 3 to the negative 2. Notice the bases are the same. Therefore, we can put one base, 3, and then take our 8 and add it with the negative 2, just like we did in the beginning. So 8 plus negative 2, I know that that is 6. So 8 plus negative 2 is 6. 3 to the 6th power is our answer because, notice, that 6 is positive. We're good. Let's look at F. N to the 9th power times n to the negative 4th power. Don't get scared because it's a letter. It's the same thing as having 2 3s, 2 n's. So we put our n down because it's the same base, and we take 9 plus negative 4. 9 plus negative 4 in my head is 5. That 5 is positive. We are now done because we have n to the positive 5. Now let's take a look at this last one here, G. 5 to the negative 1 times 5 to the negative 2. I see that the bases are the same, so follow the same rule. What do we do with the exponents? We add them. So we take negative 1 and literally add negative 2 to it, and we get negative 3. Now you might think, oh yeah, there it is, there's my answer. But it's not the answer. 5 to the negative 3 can't be the answer because they want us to write it in positive exponents. So 5 to the negative 3 actually is 1 over 5 to the positive 3. Remember, I call it flip it because this actually could be written with a 1 underneath if you really want to. And just flip it over, but get rid of that negative sign right there. There's your final answer. Now remember, you can always come back, rewatch the video, read the examples in the book, or if you need, you can even see the personal tutor videos on the online textbook. This has been a Friday Shoes production, and it is Friday.